Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is question number 8. 8.1. Determine first derivative of x from first principles if it is given that f of x is equal to negative 2x plus 3. So this is the function. I need to determine first derivative of x from the first principle. I'll show you how to solve this question. So first of all, state the definition of the derivative from first principles. The formula for finding the derivative of a function f of x from first principle is given by first derivative of x is equal to limit h approach 0 f of x plus h minus f of x over h. Now I'm going to substitute the given function f of x into the formula. So there's two ways to solve this question. I can first find the f of x plus h and then I can substitute, or one time I can solve. Same thing, answer will be the same. Now first of all, function we have here, f of x is equal to negative 2x plus 3. So if I apply the power rule to get the first derivative, so that will be negative 2, because the derivative of constant 3 is going to be 0. So when I apply the first derivative, my final answer must be negative 2. So I got the answer in advance. So now I'm gonna solve this function by first principle. Equal to h approach 0. Wherever you see x, you must add into plus h. So we got now negative 2x plus 3. So negative 2 in the function, place of x I'm going to add x plus h according to the formula, and then plus 3. In the function you add x plus h minus another function. So function we got negative 2x plus 3 over h. Now I'm gonna further solve. Till the end of this question, we're gonna apply h approach 0. When we're gonna evaluate the limits, then we're gonna drop the sign. Now h approach 0. So I'm gonna simplify here now. Negative 2 I'm gonna multiply inside, become negative 2x. Positive and negative become negative 2h plus 3. Negative become positive 2x. Negative 3 over h. Now I'm gonna further simplify. Negative and positive cancel. Positive and negative cancel. So we only got negative 2h over h. So we got h approach 0. Top is negative 2h. At the bottom is h. This h and this h is cancelled. So we only got negative 2. Since the expression no longer contains h, the limit as h approach 0 is simply the constant. So therefore, first derivative is going to be equal to negative 2. This is my final answer. You can see this answer is matching with the power rule. Earlier we found by power rule we differentiate, the answer was negative 2, and by first principle answer also negative 2. Both answers are matching, so which means my first principle calculation is correct. Now the question 8.2. Determine first derivative of g of x if g of x is equal to negative 3x power 4 plus 2x. The second, dy over dx if y is equal to, this means you have to differentiate with respect to x. This is another notation of the derivative. Y is equal to 2 x power 4 plus 1 over x power 2. I'll show you both these questions how to solve with power rule. So apply the power rule. So the first derivative of g of x is going to be 4 times 3 is 12, negative 12x, 1 power decrease become 3, and plus derivative of 2x will be 2. So this is my final answer. So I'm gonna simplify the expression for y, rewrite the function y by dividing each term in the numerator by x power 2. So it's gonna be y is equal to 2 x power 4 divided by x power 2 plus 1 over x power 2. Further simplify, because I need to differentiate, I need to apply the power rule. So x power 2 I'm gonna pull up, so become, I need to make flat this expression, so it's gonna be 2x power 2. I apply the exponent rule here. When you divide, the power must minus, so x power 4 minus x power 2, answer will be x power 2, plus this x power 2 I pull up become x power negative 2, positive power become negative when I pull up. So the y function we got y is equal to 2. So now we got function y is equal to 2x power 2 plus x power negative 2. Now I'm gonna apply the power rule, differentiate y with respect to x. So using the power rule, so I'm gonna pull this question this side. So the dy over dx is equal to 2 times 2 is 4 x power 1, and this become negative 2 x power negative 3. When you differentiate, power must minus. So I'm gonna rewrite the expression now. 4x and negative 2 and x power negative 3 I pull down become positive x power 3. Even you can leave answer in this form will be correct, but appropriate to write the final expression with the positive exponents. So this is my final answer. This is the question number 9 in front of me, mathematics paper 1 and SC certificate, DBE November 2025. Question number 9, calculus question. The question says sketch below is the graph of f of x is equal to x power 3 minus 8x power 2 plus 5x plus 14. A, B, and C are the x-intercept of f. D and E are the turning points of f. So this A, B, C are the x-intercept and D and E are the turning points. This is the information of the sketch. The first question 9.1 says calculate the coordinates of E. So here looking this coordinates of E, turning points of f. So the first of all, find the first derivative of the function. The turning point of f of x occur where the first derivative is equal to 0. Now the function is given by f of x is equal to x power 3 minus 8x power 2 plus 5x plus 14. So the first derivative is 3x power 2 minus 16x plus 5. The derivative of constant 14 will be 0. So the 3x power 2 minus 16x plus 5 is equal to 0. So it's going to be 3x minus 1. I'm going to factorize. X negative 5 is equal to 0. I factorize. So if you can't factorize, then you can use the quadratic formula as well. The x coordinates of the turning points are, so the first here, x is equal to, this negative 1 become positive 1, this is going to be 1 over 3, or x is equal to positive 5. Now determine which x coordinates correspond to E. From the graph point D, have a look here. The local minimum occurs at the larger x value. Therefore, the x coordinate of E is x equal to 5. X equal to 5, because this is a positive x-axis, this is a point of origin, so which means x 1 over 3 will be here, so x is equal to 5, that must be somewhere here, so we're going to take x equal to 5, that is the x coordinate of E. Now find the y coordinate of E. Substitute x equal to 5 into the original function f of x to find the y coordinate of E. So we need to x equal to 5, I'm going to substitute into this original function here to get the y value. So I substitute x equal to 5 into the original function f of x to find the y coordinates. So thus will be, I use my calculator one time, the answer will be negative 36. So x value, the E coordinates gonna be, x value is 5 and y value is negative 36. So this is my final answer. 9.2. For which values of x is f concave down? Find the second derivative of the function. Concavity is determined by the second derivative. Second derivative of f of x. The function is concave down when second derivative is less than 0. The first derivative is, we have first derivative. The second derivative is, so this is the first derivative. Second derivative is 3 times 2 is 6x minus 16. So this is my second derivative. Graph concave up or concave down, we only can see from the point of inflection. So we need to find the point of inflection. So set the second derivative to 0 to find the x value. 6x negative 16 is equal to 0. Solve for x here. Positive 16, both sides divide by 6. So it's gonna be a 16 divided by 6. So the x gonna be, use my calculator, answer is 8 over 3. So this is my point of inflection. So positive 8 over 3. So x equal to 8 over 3, this is the point of inflection. Must remember coordinate of B is given 2 and 0. Positive 2 and 0. So, and the D earlier we found is 1 over 3 x value, and the E we got x value 5. So which mean 8 over 3 2 comma 67, and that will be somewhere here. So the 8 over 3, this is, we have the point of inflection. Now we can see where the graph concave up or concave down. He want to know where is the graph concave down. So he want to know where is the graph concave down. So you can see the graph concave down till the point of inflection, and from here graph concave up. So he want to know where is the graph concave down. So this is the graph concave down till the point of inflection. So the answer will be x less than 8 over 3, the graph is concave down. This is my answer. Question 9.3, very interesting question. The coordinates of B are 2 and 0. Use the graph to determine the values of x for which f of x multiply second derivative of x less than 0, which means negative. I'll show you how to solve this question. So to determine the values of x for which f of x multiply second derivative of x less than 0, which means negative. This inequality is satisfied when f of x and second derivative of x have opposite signs. This occurs in two scenarios. So you need to write here f of x. We must make a table f of x. And then we go to second derivative table, second derivative of x. The answer must be negative, less than 0. So the first scenario, f of x must be positive and the second derivative must be negative, then answer will be negative. Second scenario, f of x must be negative and the first derivative must be positive, then answer going to be negative. So we have to look these both scenarios. So now, find the x-intercept of f of x. The coordinates of b are given as 2 and 0. This means x negative 2 is a factor of f of x. So we need to find the x-intercepts of a and c. So we have the function f of x. So this is the function f of x. X negative 2 is a factor. Now we need to find the, I'm going to use the synthetic division to find the other x-intercepts. So first of all, I'm going to write the list all the coefficient of f of x. 1, negative 8, positive 5 and positive 14. And I'm gonna divide by 2, because if I need to find the x is a liar, if I need to find the x value, x negative 2 is equal to 0, x value gonna be positive 2. So the 2 is a divisor. First of all, the first coefficient I pull down. Now 2 multiply 1 is positive 2, and now I add, the answer is negative 6. Negative 6 multiply 2 is negative 12. I add, the answer is negative 7. Negative 7 multiply 2 is answer is negative 14. I add, answer is 0. If you see at the last is 0, which means x negative 2 is a factor. Now ax square plus bx plus c, this is the quadratic equation. This is the long bracket. Short bracket, we already got x negative 2. Now I find the long bracket through synthetic division. So this is the first one. This is the coefficient of x square is 1. So you're gonna write here x negative 2, and this become x square, and this become negative 6x, and the c is negative 7 equal to 0, because we need to find the x-intercept. So we apply the 0 factor rule, because we need to solve for x here. So I'm gonna factorize the second long bracket. So the x negative 2, so I'm gonna factorize the second long bracket, x negative 7 x plus 1. After I factorize, these are my factors. Now I can solve for x. So this is x is equal to positive 2, and this is x is equal to positive 7, and this is x is equal to negative 1. So I've got 3 x-intercepts. So the b we already know is 2 and 0. This is the b. So the a laying by the negative section, so the a gonna be a negative 1 and 0, and the c is laying further from the b, that's gonna be 7 and 0. So these are my 3 x-intercepts. So a is negative 1 and 0, and the c is positive 7 and 0. Now use the results from question 9.2, which we already got the point of inflection, that is 8/3, which is here. So 8/3, this is my point of inflection. Now analyze the scenarios. So the scenario 1 I'm going to analyze first. F of x is positive and the second derivative is negative. So first we need to see where is the second derivative is negative. So first we look f of x. Above the x-axis, f of x is positive. And below the x-axis, f of x is negative. This is x-axis. Below the x-axis, negative. Above the x-axis, positive. Now we look at the second derivative. Concave down till the point of inflection. And from here, concave up. So the graph is concave down till the point of inflection, and from the point of inflection the graph is concave up. So the second derivative is negative and the graph is concave down. So this is a negative, negative, and negative, negative, negative. And where is the graph concave up? Second derivative is positive. So analyze the scenarios. The first scenario, f of x positive, second derivative must be negative. Positive and negative, answer is going to be negative. So now we look where is f of x positive. I'm going to highlight with different color. This is f of x is positive above the x-axis till here, till the point P. Now second derivative must be negative according to the first scenario. Second derivative must be negative. Now we look where is the second derivative negative. So I'm going to use the another highlighter now. So the second derivative is negative all the way. They're going, this is also included till this point of inflection. Now we look where is f of x positive, the second derivative negative. So only at this, I'm going to highlight now different color, only at this place till from point A till point B, the f of x is above the x-axis positive and the second derivative is negative. So answer gonna be between -1 and +2. That's gonna be my first interval. So first answer gonna be between -1 and +2. This is my first interval. Now now we look at the positive section. Second scenario, f of x must be negative, second derivative must be positive, then answer gonna be negative. Now we need to look at the second scenario. F of x is negative below the x-axis. F of x is negative below the x-axis. So now you can see here, this is negative all the way. F of x is negative. I highlighted with the blue color. Now second derivative must be positive, so concave up. So from this point of inflection, second derivative is positive all the way. You can see so on. Now f of x is negative, second derivative positive. From the point of inflection, you can see from here, second derivative is positive and the f of x is negative till this point C. So my second interval will be between 8/3 and +7. That's my answer. I've got two interval between -1 and 2, and the second one is between 8/3 and 7. 9.4 says, for which values of t will y is equal to -11x plus t intersect f at three distinct points. I'll show you how to solve this question. Must remember, y is equal to -11x plus t. This is the straight line, and then -11 is a gradient and t is the y-intercept, and obviously this is a negative gradient line. Is gonna be from top till bottom. So this is a negative gradient line. Now at usually we got f of x, and then in the f of x you find sometime plus k or sometime f of x is equal to k, same thing. Now, which means the y is equal to k, is new y-intercept equal to k. Then we draw the horizontal line, and then we see where the graph touching, where this line touch the graph thrice, like this 1, 2, 3. Then we give the answer, and you can watch my k method video. I explain this topic in detail there, right? Now, but this is not gonna work on that way, because this is a horizontal parallel to x-axis. We draw the horizontal line, same like uh, we draw in hyperbola horizontal asymptote, y is equal to something. So this is going to be y is equal to k, but this is not going to work. So because we have the line now, y is equal to negative 11x plus t. This is a straight line. The gradient is negative 11. So I'll show you how to solve this one. Normally these type of question, when they ask you to find the three distinct points, then we always look between the two turning points. But this question is a little bit different, so I'll show you how to solve this one. The line y is equal to negative 11x plus t has a fixed gradient of negative 11. The value of t is the y-intercept, so this is a y-intercept. The line will intersect the curve f of x at three distinct points for a range of t values. So we need to find the values of t. The critical values of t occur when the line is tangent to the curve between turning points D and E. The gradient of the curve at any point is first derivative is equal to 3x square minus 16x plus 5. Earlier we found, must remember. So this is f of x, and the first derivative earlier we found 3x square minus 16x plus 5. So must remember the gradient of the curve at any point is first derivative is equal to 3x square minus 16x plus 5. So we need to find the x values where the tangent gradient is negative 11. So must remember, set the first derivative equal to negative 11, because the tangent line, the gradient of the tangent line and the first derivative, they are equal at the point of contact. So the 3x square minus 16x plus 5 is equal to negative 11. We're going to equate. So this becomes 3x square minus 16x. This becomes positive 16 is equal to 0. We need to solve for x here. So we simplify. This is going to be a 3. We're going to factorize 3x negative 4 and x negative 4 is equal to 0. I factorize this expression. So now we need to find the x values here. X is equal to negative 3 become positive 4, 4 over 3, or x become equal to positive 4. So we got two values. Find the y values on the curve at these x values. So we need to substitute into the original function here to get the y value. So I substitute x equal to 4 over 3 into the original function. I get the y value 230 over 27, and if I substitute x equal to 4, I get the y value negative 30. Now find the critical values of t now. Now we need to find the critical values of t. Now we need to calculate the corresponding t values for the tangent lines. So we got two tangent lines. Why? Because x2, we got two x values. So the first tangent point is 4 over 3. The y value is 238 over 27. So this is the first pair. X value 4 over 3, y value 238 over 27. Now, So y is equal to negative 11x plus t. Now we substitute into this equation to find the t value. 238 over 27 is equal to negative 11 multiply 4 over 3 plus t. Further simplify, 238 over 27 is equal to negative 44 over 3 plus t. Negative 44 over 3 plus t. Now we need to solve for t here. This is the y-intercept gonna be. That's gonna be a t. It's negative 44 over 3. I pull over this side, become positive. So there's gonna be t 238 over 27 plus 44 over 3. I use the calculator. My answer will be, therefore t is equal to, I use the calculator, 23,48. This is my t value. Now for the
second tangent point.
4 and x value 4, y value negative 30. Now we're going to substitute into the y is equal to negative 11x plus t to solve for t. Now this become negative 30 over negative 11 multiply 4 plus t. Negative 30 is equal to negative 44 plus t, and this negative 44, I switch over this side, become positive 44 is equal to t. Therefore the t is going to be equal to 14. So the line will intersect the curve at 3 distinct points for t values between the two critical values. So the answer will be, therefore answer will be, t will be between 14 and 23,48. My final answer. Therefore the t will be between 14 and 23,48. This is my final answer. This is the optimization question in front of me, question 10. The question says a rectangular metal sheet has dimensions x and h units with x greater than h and a perimeter of 50 units. The metal sheet is rolled into a cylinder with two open ends, top and bottom, and height h units. So this x is the circumference of the cylinder and h is the height of the cylinder. Now the first question says, show that the volume of the cylinder is given by V is equal to 25x square over 4 pi minus x cube over 4 pi. So we need to prove this one. I'll show you how to solve this question. Now to solve this question, we need to formulate perimeter and circumference equations. So he said x and h and the perimeter is 50 units, and must remember x must be greater than h. That we need at the last is. The perimeter of the rectangular sheet is 50 units. So 2x plus 2h is equal to 50. Must remember this is a rectangle and the perimeter x is 1, x is here, and opposite side is also x. This is h, opposite side is also h. So 2x plus 2h is equal to 50. Now, so 2 is common, so we left with x plus h is equal to 50. Both sides you divide by 2, the answer will be 25. Now we need to find the h here. So the h will be 25, positive x become negative minus x. So we got the value of h. Now must remember, when rolled into a cylinder with height, the dimension x. Must remember, when rolled into a cylinder with height h, the dimension x, this one, becomes the circumference of the base. So becomes circumference of the cylinder. Now circumference of the cylinder we need to find now. C is equal to 2 pi r. This is the formula of the circumference, and circumference we got x 2 pi r. Now we need to find the r value here. That will be x over 2 pi. So we got the r. Now formulate the volume equation. So the volume is equal to pi r square h. This is the volume of the cylinder. Now we need to substitute the expression for r and h. So pi r we found earlier, that is x over 2 pi square, and h we already found earlier also, 25 minus x. Now we're going to solve further. Pi, this become x square over 4 pi square. 25 minus x. Now we need to simplify. This pi cancel with this 1 pi, so we only left with the x square over 4, and when I multiply it become 25x square. X square multiplied by 20, and then x square multiplied by x become x cube, and at the bottom is 4 pi, because 1 pi is cancelled with that, so 4 pi. Now I can write the answer in terms of how you want in this form, because 4 pi is a common. I'm going to put the answer this side. Therefore you're going to say volume is equal to 25 x square over 4 pi and minus x cube over 4 pi. So the volume of the cylinder is given by this equation matching with this one. So my answer is correctly proved. Second question, he says calculate the value of x that will maximize the volume of the cylinder. So we need to find the maximum x value. So now we need to differentiate the volume function with respect to x. To find the maximum volume, differentiate the volume function with respect to x. So it's going to be dv over dx. We're going to differentiate with respect to x. We don't need to pull the pi up because pi is a constant. So this becomes 50x over 4 pi minus 3x power 2 over 4 pi. Now set the derivative to 0 and solve for x. So 50x over 4 pi minus 3x square over 4 pi is equal to 0. So we need to get rid of the denominator, multiply with 4 pi. So the 4 pi cancel with 4 pi, only left 50x. Also 4 pi cancel, only left 3x square is equal to 0. Now x is a common here. So we left with 50 minus 3x is equal to 0. Solve for x. I'm going to pull over this question this side. X become equal to 0, or 50 minus 3x is equal to 0. So this become negative 3x is equal to negative 50. To find the value of x, 50 divided by 3, that will be answer. So we got 2x value. Now must remember, he said earlier he said the x must be greater than h. So we got two value, x equal to 0 and x equal to 50 over 3. We need to choose one. Must remember, in the question statement he said x must be greater than h. Now so h value we got earlier, we found 25 minus x. So 25 x value we got now 0, and the second x value we got 50 over 3. I'm going to substitute 50 over 3 here, and I simplify, use the calculator. The answer becomes 25 over 3. Now, therefore, I'm going to use the x equal to 50 over 3. Why? Because according to this statement, x must be greater than h. So in this case, 50 over 3 is greater than 25 over 3. That's why therefore the maximum value is going to be 50 over 3. This is my final answer. And you can apply the second derivative test also to check your answer is correct or not. This is an additional explanation. If you want to write in exam is fine, or otherwise you don't need to write is also fine, but you can confirm the second derivative test confirms that this is the maximum point. So we are going to apply the second derivative. This is the first derivative we have. Apply the second derivative here with respect to x. That's going to be a 50 minus 6x. Now we need to substitute x value here. 50 minus 6 x, we got 50 over 3. Answer become negative 50, so which is less than 0. So which means x equal to 50 over 3. Correct answer. This is a maximum value. This is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day. Next video I will upload about probability question 11.